Yes, hello again, and now we are ready. Yes, thank you, Greg. Nice talk, and yeah, also very good to talk with you all these years now. Actually, I think the planning of this event was a good example of high efficiency. Just 4 weeks ago we actually talked, and then we set up a program together with Torben very fast, right? So we should continue that road also in the digitalization platforms that we would like to do. I have some slides actually that I hope will show here, maybe. I hope. Yeah. Yes, thank you. So today I'm representing the Building Wood community, and that was what I will give my welcome minutes here for to show you a bit about that. But before, that's a short bio of mine. I will not go into all those details, but I'm working at the Danish Technological Institute. I have a Master's Science of Education. Have been at the institute for many years, focusing on using wood and biomaterial in the construction sector. So when we have a lot of projects, our institute is focusing on different things. We have a large institute in Denmark, not large in the worldwide sizes. We have around 1,000 employees, and we have a lot of, luckily enough, satisfied customers. We are what we call, let's say, self-owned, not-for-profit institution. So that means that we are not owned by anybody. So the things that we earn, we invest in our, let's say, business development. We are also approved as research and technology institution, and therefore we are doing, let's say, work where we do independent consultancy for the business, helping the business to focus on their goals. We have a focus and strategic focus on the green transition, on food materials and energy, and also on digitalization. So that fits very well with what we are talking about here. And to be a bit more focused before going into the building wood community. One of the things that has been a kind of a change from our side is that we 5 years ago planned to go for an EU call on a project. We wrote a proposal. We were granted a proposal called Building Wood. Has been running now for 4 years. And we'll end this year. It's a huge budget, 10 million euros. It's huge for us. It's not huge in the numbers that Greg can mention, but anyways, this has been very good to have the focus. And the focus with this project has been to have wood to be a more natural choice in the construction sector when it comes to multi-story buildings. And here we are focused on the load-bearing structure. Not as much as the facade, but here on the load-bearing structures of this. And we have great partners from, as you could see, 12 different countries, 21 partners here, representing the whole value chain. And they are very, let's say, part of this good work that we are trying to do, because we are not setting in on one specific topic. We are actually trying to improve the value chain in different parts of it. And one of these different parts is actually creating an international network. We have promised to do that, and we are trying to do it with the Building Wood community. So why are we doing this? Well, looking at the sector, looking at the value chain, we see this as a very fragmented sector. We would like to kind of join forces, be more easy to get networking to work. So that's what has been the starting point from our community thoughts. And one important point is that we are trying to introduce this, but having a community to work, it needs to be the members, let's say, community in order to have this to be let's say, long lasting and to be content-wise something that is valuable for the sector. We again have the same vision as we had with the Building Wood project. We actually like to have a bit more better understanding of using woods in all of the value chain. Of course, we are sitting many here today, maybe very eager to have this to work, but there's also maybe 90% out there that is not it's not that common for them to use timber in this way that we would like to do in the future. So we had a digital platform. We are 1,200 plus members right now. We should be 10, 20 times that many before it becomes really good. But I think it's a good development. It's work in progress, still being online, but still work in progress. So any input for any of you is valuable. How can we improve this better to support all of your ideas and thoughts? So that was a few words from my side. I have more slides, but Greg said, please hold on the slides. Right? But I think we have more of the things. I'm very, very excited to hear all the great keynote speakers here today. And thank you for the opportunity. Have a nice day.
Yeah, and thanks. I do want to mention, we've done a lot of projects, but it isn't about that, us showing all these buildings we've done. I think a lot of people here can show amazing buildings. The real focus and my goal of coming here is how do we make more connections? How do we provide more innovation, more opportunities for the people who want to do this? And so we'll now bring up some presentations and see some amazing projects from here in the Nordics, as well as some internationally, in other countries, including the US. Are we ready for the next? Okay. There we go. And rather than give introductions, I think people will be introducing their work and themselves through their presentation. Thank you.
I have a mic.
You're all mic'd. Excuse me.
Hi, thanks for being here. My name is Martin Stenberg. I'm from Henning Larsen Architects. And I'm going to present this project to you. It's an experience center for Volvo that we have been working with since 2018 in Gothenburg in Sweden. Let's see. We started this, it was an interview competition in 2018 where we were selected as the architect. And it was really about a journey for Volvo as well. It's two companies. It's a car company which was sold off in the 90s to a Chinese company who now owns them, and then it's the AB Volvo also who co-own the brand of Volvo together, which wanted to do this building, which sort of showcase them and what they want to do in the future with mobility and the future of transportation industry. And then we worked a lot with them as architects. That was sort of a new thing for us to work with a brand in such a deep way and deep understanding of what they wanted to go with and sort of their future perspective of what they wanted to transition into. So this, instead of being a sort of a traditional museum for vehicles, it was going to be much more of a sort of an expression of what their future view of society and their relationship to society would be about. And we came up with this, that we move you, or Volvo moves you, the people that came from sort of an understanding of Swedish culture and what built Sweden, and that Volvo has sort of been a part of that, the sort of bringing people and getting people access to a vast country with different types of nature and so on. It was a huge part of the inspiration and the source for this project. And we wanted to create sort of a journey through that project, that the project was a journey for people to experience both Volvo and the society of Sweden and so on, and what we wanted to do with this project. We started early on, before we started to draw anything, to work with Volvo about creating a vision for this project, what that would be and what they wanted to do and the impact they wanted to do with this project. And it was about, of course, creating a landmark, doing something in the center of Gothenburg, the first time they did that. It was about creating a meeting place or gather people, which is a big part of their focus. Premiumness, what would that be in architecture? I'll come to that. And then sustainability, of course, that led us into making this as a mass timber project. One of the aspects, at least. here's the site. You see on the north side of Gothenburg, there's all the factory areas and where they have been located, both companies. Previously, there's a museum. They have here a more traditional sort of vehicle museum. And they wanted with this project to locate in the city center or in the sort of the other part of Gothenburg, the more central part of Gothenburg, and be a part of the urban fabric. And as architects in Henning Larsen, we always work with different scales. Of course, we're mainly architects, but we work also with urbanism and sort of give the buildings more value in terms of looking at buildings in a larger context, of course, as well. And landscape, which was became a big part of this building as well. And sort of the location led us into bringing landscape and city, and sort of that merge was a big part of the inspiration. When it comes to digitalization, which is a big part of what we're talking about today, we of course work with a lot of different tools. And this was part of the tools that we worked with initially or very early on to study sort of the location of how the building should work and the placement of the building. It's about microclimate, looking at what could be potentially good outdoor areas for people to hang out in. It's about paths and circulation on the site and connection to the rest of the conditions around it. A lot of noise. It's just about up to a freeway. So there was a lot of these sort of studies that we did with the engineers in our team. Let's see if I can get it to. And of course collect and sort of data analyze that could then lead us into sort of coming into the more design-wise, the questions that it's about. We always as architects work sort of in a holistic approach when it comes to technology and data collection, sustainability as an overall objective, of course, with everything we do, and we try always to strive for the best type of design. Going into the project, when it comes to the landmark thing, of course, it's sort of also relating to the brand. It needed to be round. The location also seemed like that was the right choice. We have a lot of different sort of surroundings. We have a freeway on one side, a river on the other side. So there's a lot of sort of reasons why we did it round as well. Here you see the section. There was also another client which was a big part of. This is not a wooden project, unfortunately, but it's actually for another client. It's a big parking garage for the amusement park, which is beside it. But we tried to sort of use that and make that into a landscape and dig down those parkings into a landscape, which was able then for the wooden part of the Volvo project to come up and be visible towards the freeway and create a sort of a pedestrian zone towards the river. Conceptually, we wanted to also sort of take that piece of Sweden as a landscape, a natural habitat for strengthening also the biodiversity in the area, as well as sort of the cultural thing of building in wood and strengthening that in Sweden as well. When it comes to the path of going from that idea to the actual build, it's of course a super complex. I think Stefan is going to come into the more manufacturing part of this after me, but it's of course a very complex wooden structure that we created, and it was really derived from that initial thoughts about sort of a journey through a project, and to that vision of, okay, what is that the big landscape with that pavilion, the wooden pavilion sitting in it, and the experience of how you, or what you experience within that, both within the wooden structure but also on that landscape. So it was really about a lot of digital craftsmanship when it comes to, we work with Grasshopper and Rhino mostly as the tools for this, and developing both sort of you see here the geometry, how it derives from a sort of a perfect triangle, and those circles come out of a wish from the client to have some of the exhibition functions as a black box function where you don't have daylight and so on. So those boxes were then shaped according to the client's demand of the sizes of those functions, and then sort of the structure derived from those circles and the shape of those and the demand from the client. Of course, it's a complex geometry where we worked very closely when VHAG was selected as together with Lindner that did the project management of their part. When they were selected as the structural engineer plus the manufacturer of the wood structure, we worked closely with them in figuring out the dimensions of these ones. These are the most massive ones. They are 1.2 meters high, 1.8 meters high, and 600 millimeters wide. So it's huge, massive beams that spans. The longest spans are probably here. It's 55, 60 meters without support. And of course, it's sort of when you can create these mathematical scripts, it's easy to also look at it and work with the engineers and sort of slide the amount of beams and structure you need for the support and very easily test out what that does with the architecture and what that does with the room inside and sort of find the correct balance. Up to when we go and see the final prototypes with this my colleague Philip here who fell in love at site when we saw the first prototypes of these massive beams and the connectors. This is from the build site. It's like a year ago, I think. So I think Stefan has more updated pictures of the build site. But it's been a fantastic process to see this from those early sketches and seeing how that structure comes alive and creates rooms underneath it. Programming-wise, just shortly before my time is out, it's a huge program for Volvo. They wanted to have, vehicle handover where customers can come and pick up both a truck, a bus, and a car. It was a big exhibition, of course. That's the main focus with the building, but it's also a lot of events and event halls and conference facilities and all kinds of those meeting facilities that supports both them and their sort of outreach to society and the community around it. This is how it's going to be looking towards that pedestrian zone, the riverfront, and then how it sort of comes up and creates this big podium for the exhibition towards the freeway. And then there's this hidden gem on the top, which is a pavilion with a nice restaurant and some meeting facilities and also some smaller exhibition spaces up here on the roof, which is that sort of hidden pavilion which you need to experience through walking into the wood structure and coming up in the sort of going through the tree trunks up in the tree canopy. Some visuals from that. I think this is my last slide. Thanks.
Okay, hey, my name is Stefan Abrahamsson. We were the contractors for the job. So, and I represent Lindner Scandinavia as well as VHAG, which is represented by John over there, who is the wooden manufacturer. To explain, as Martin has done, we had the contract from BRA, the client, for in principle all the stuff that you see on the pictures, the facades, the glue lamp, and all the acoustic panels that form the barge of the tree trunks. We had a good team. We had the architects, and we had the client and the Volvo guy, and all the team from VHAG, and it worked really well together the whole time. The time issue here was quite critical. We were supposed to start on the 4th of April in 22 and be finished and have a sealed building by mid-October 22. So we had a very short time span. And it's a lot of timber. It's 6,000 cubic meters of finished product to be installed by coming in 160 lorries and to be installed in this short time. The build-up is quite complicated of all these landscapes and things. It's done in glue lam and CLT. And the glass facades are wrapping around the complete building, fitting the heights of the different landscapes around it, and fitting the grid of the column. So the glass is like 6 by 2.4 meter size, so it's quite large. Just the current picture from the hidden gem on the top. It's now finished with all the sedum roof applied on the outside, and it looks really nice. Acoustic panels, totally in timber, as well as the carrying structures. It gives the sound absorption to the rooms, as well as forming a nice surface for the trees. It's introduced everywhere, and it's also soffits and all kinds of things in timber. So now we're gonna have a summary movie which we have taken snapshots during the time that we actually installed it. Here's the first truck coming from Austria. It's the beam. Good. So it's a 35-meter beam that we had to close the streets to stop the trains to get it in. And it's lifted. It's so heavy we had to use 2 cranes to lift it in because 1 crane couldn't do it. So this is the first beam that we installed, and from that we build it out in like a cathedral shape. 3 cathedrals which are in the middle. And it's all supposed to be hidden connections. So inside here, there's a lot of steel. I think it's around 160 tons of steel. But it's all hidden in the end by these cover plates. The cover plates has 2 functions. They protect, they hide the steel, and they protect the steel from fire. So here's a few weeks later, we started to install the CLT. It's around 18,000 square meters of CLT in the project, so it's a quite big function. And in such a project, one of the main concerns is water and rain. So the main idea was to get the roofer guy to come really shortly after we have installed the CLT, and then put the tar paper on so the water goes away. And as we said, time is critical, so as soon as VHAG has installed the wood and are finished on the roof, we will start installing the brackets for the facades, and then follow with the facades around the building. So we basically end up at the same place at the same time. Yeah, the building is 110 meters across. So if you stand in one end, I think it's 90-something meters inside. So you can see straight through, and there's no columns. It's just open, the whole thing. It was supposed to be self-supporting, so we're not allowed to have any crosses in the structure, so it would be stiff enough to do it. Here we are starting to install the pavilions, and you get a feeling for how it's going to look in the end. There's a stairway which wraps around the hub C all the way to the top, and all the decks are in CLT, and everything is actually in wood, except the cores for the stairways and the elevators. This is a quick drive up the stairs. But as you see, it's a lot of pieces, and tolerance from VHAG is within millimeters on all the beams, and we have not had any rejections. Everything fitted together really well, and very minimal cutting on site. If you see a guy with a big chainsaw on a site, tell him to go away and go home, and figure out what's wrong instead. Yeah, the facade is coming on the pavilion, and it's working in many layers at the same time to be able to finish the project. The tar paper is working as the diffusion layer from the inside. So all the wood is on the dry inside. So if there is leakage or something, it can always dry out inwards. It was drawn some box system from the start, but we changed it to a solid CLT system with all the insulation and everything on the top. So now we're coming to the end here soon. Now we do the exit from the movie. But you see, this, the wood is quite popular in Gothenburg. They're making a swimming arena just beside it, all in wood and ETFE. And 35 weeks to build the whole structure. How did we come about this? Martin, who works with Rhino and Grasshopper, we do the same. But to be able to generate drawings, production drawings, we take this information into Tekla, which is a steel program from the start. But it can draw many things from this. So now we're going to show you a small movie on how it's actually done. I hope. Nej. Vi får sätta på filmen där. Där var han. When we get the model from Martin and his crew, we take it into Rhino and Grasshopper again, and they generate the glass, outer surface of the glass. Usually when we get some information done in Revit or something, there are no modular lines left. It's only a gap. We cannot work with the gap. We have to have the total geometry in surfaces to be able to define outside of the glass and then build inwards or inside of the glass or whatever we do. So here we generate all the shapes of the glass in Rhino and Grasshopper. And then we decide the composition of the glass. If we have different, like we have fire glass in one place, we have regular glass or other things. And we then decide which type of glass it is. And then we have the thickness of the pockets. We have little pockets because it's a silicone seal system. So we have to introduce pockets into the glass. And then we can see how it looks in a small test glass on the model. So here is checking the different. I will see. So it's making the sample. So we can. This is the offset. How much we take decrease the glass from the modular lines to be able to fit it. He introduces the pocket system. Distance between them. And then he decides on where they should be, top, right, bottom. And then he applies the whole thing to the Tekla model. So we know which type of glass is where. We can check that, so it's proper. And then he generates from Rhino, he generates all the models into Tekla, which we then can make part drawings from and make production drawings. So this is our way to digitalize and benefit from Martin's work before, and take that on, and not just start from zero again. And the same applies to VIAG. They take these models and they start the calculation from that. So in the model, all the details are the pre-fitted top and bottoms. The brackets you saw on the movie is all there. We can install the glass in theory before we come to the site, see everything fits. Especially in these strange shapes, it's good to have a visual check instead of trying to check drawings. It's very difficult. We can here see where the pockets are situated and supports and rubber gaskets, whatever you like. So this is our team of 15 engineers. They are working on these things to make it fit. And then we make production drawings, get it produced by somebody, and then we install it on site in our own teams. I think that's done. We use it also for the interiors. This is the acoustic panels, and they are generated by this mass of lines. Totally crazy things. But still, it comes out like this. And this is a mock-up we have done to show the architect we have in the office. So when we have an opening, we have to make curved timber, and then we have to make straight. This is, yes, something else. And then inside the hub C, we do wall claddings, like a kidney shape, and we have to make guardrails in timber for all the different shapes of the decks. And it's all done by these rhino and grasshopper things. You understand that it's not me who does it, it's somebody else. And we also do the soffits in the same way. So we have the thing, and then we can incorporate everything into one model, and then we have a finished product. For example, here we have to make a 3D curved soffit under the stairs. We then design it in the software. We then send these cutouts to VHAG, and they come pre-made from Austria, and then we can just install the all-wooden floor. There was one thing more that we were asked to talk about, and it was timber facades. Since we're a facade company, we have also made a all timber system. So this is probably the first office building in the world where the facade is totally in timber. It consists of a big glass box to the front, and normal office facades on the back, and 2.5-story high facade down here. So these parts are stick built. These are glass roofs. And when we check the CO2 improvement by doing an all timber roof compared to steel and glass roof, we improved the CO2 level with 135%. So it's actually a negative value for the frame of this roof. Architectural images. We all, to prove these new systems, we do tests, mock-ups, show the client. We have test results. We have very good pressure values, up to 1500 pascals. Usually a window can take 600 maybe. And we base the whole system on standard glue lamp sections. It's here, this one. Basic 225 by 56, and on the bottom of the window, 90 high. And then we can build, and what you see from the inside is then all wood. This is the finished product where we have installed the main frame. We are in a hybrid situation where we have primary timber and hang the decks from the top of the columns and install the concrete decks onto the wood. And then we install the secondary structure for the facade on the decks. That was it. Thank you.
Hi, everybody. I don't have any slides. You're just going to have to listen to me. I'm Steve Marshall, and my company is Mass Timber Strategy. I'm based in Washington, D.C., on the East Coast of the U.S., and my main role is helping people in the U.S. that are trying to work with mass timber at scale, at large scale. So the two primary things I'm working on right now, I'm working with one development company that is looking at a very large deployment of mass timber buildings. It's too early to get into the specifics of that, but if that's successful, you'll know it. It'll be quite something. I'm also on the other side of the country working with a small nonprofit organization, the Sierra Institute, and we're looking at introducing a series of very small cross-laminated timber fabrication facilities into the U.S. So far, most of the focus on the fabrication in the U.S. has been very large factories, and those are important, but we also think there's a place for smaller production facilities, and we're working on piloting that in California right now. That's coming along pretty well. I'm celebrating this year 2 separate anniversaries for mass timber in the U.S., and I'll get to that, what those 2 anniversaries are in just one second. But before that, I want to tell you, coming through customs yesterday, I had a flashback. And it was several years ago, I was going through customs at Heathrow, going into London, and the guy asked me, "What are you here for?" And I said, "I'm here for work." And he goes, "Well, what's the work?" And I said, "Well, I'm coming to talk to people about wood." And he said, "What do you mean?" And I said, "Well, wood construction and buildings." And he goes, "Wait a minute. Why would you come here? You're from the U.S. You build more wood buildings than anyone else in the world." This is the customs guy telling me this. And my response to him was, well, we've all got stuff we can learn from each other. And that's my message today, too. We've all got stuff we can learn from each other, and that's why I'm here. But I had that coming through customs yesterday, that flashback. What on earth is this guy, how does he know this? He actually had the statistics. It was just caught me completely off guard. So back to the teaser, the 2 anniversaries. 100 years ago, this year, the United States Patent Office issued a patent for cross-laminated timber. It went to a small wood manufacturing company in Tacoma, Washington, which is just a little ways south of Seattle. Near as I can tell, we kind of forgot about it for the next 90 years. I don't know if anything ever was, if they ever manufactured any of that material they got patented, if it was ever used. I don't know any of that. But what I do know is when you read that patent application, the reasons they said it made sense and the reason it was worthy of a patent, it's a lot of the same stuff we talk about today. It's amazing to go back and see people looking at this 100 years ago. Embodied carbon was not part of the application, but the attributes of what happened when you do the cross-lamination, they nailed it 100 years ago this year. This is also the 10th anniversary for when the U.S. federal government decided to get serious about mass timber. And I was working for the federal government at the time and was part of the decision-making process to take that deep plunge. And it was in August 10 years ago the decision was made. And we wanted to do it big. And so the first visible expression of us doing this, we held a White House summit on wood and green building. And that was kind of our coming out party to let the world know we're going to be making a serious thrust on this. A lot of stuff's happened since then. At that time, I could only find 5 structures in the U.S. that had any CLT in them, only one of which was actually a building built of CLT. The others there was a component somewhere in the building. We have more factories making CLT in the U.S. today than we had buildings with CLT in them 10 years ago. That is a phenomenal growth curve, folks. Absolutely phenomenal. Greg put the map up of the projects in the U.S. If you looked at the detailed data behind that map, there have been about 800 mass timber buildings that have gone up in the last 10 years in the U.S., about half of those being CLT, the other half being a mix of other mass timber products. There are more than 900 projects currently under design in the U.S., And as impressive as those numbers are, they don't tell the whole story because the projects are getting bigger too. So it's not just the number of projects, but the scale of the projects is changing. I'm sure many of you are familiar with the tall building in Milwaukee, 26 stories. That's big. Our largest building in the U.S. right now is a massive apartment building called Intro in Cleveland. It's a huge project. There are things on the drawing boards right now that are bigger than that. So things are really clicking along. Some of what's made that pace possible is the single biggest one is the accomplishments that had already been made in Europe. We're playing off of what people spent years and years pioneering here. And to this day, the dialogue back and forth is critical. We couldn't be doing what we're doing without that. Another thing that is perhaps unique in the U.S., we have the U.S. Department of Agriculture has an agency called the Agricultural Marketing Service. In the U.S., timber is regulated as an agricultural product. And so the AMS authorizes all the timber mills in the U.S. and in this instance in Canada as well to band together on a self-tax where the money can be used for research and education purposes. And as part of that education, this body, it's called the Softwood Lumber Board, this body pumps a lot of money into Woodworks, the organization that produced that chart that Greg showed. The main thing that Woodworks does in the U.S. is they provide free advisory services to people that are looking at using mass timber. So they have a staff of engineers and architects across the country where any developer can go in, and they still need to have their own architects and engineers, but they can be advised into the world of mass timber by this network all across the country, and that's free of charge by way of this self-tax that the timber mills are paying. And so I don't know of other examples like that around the world. Maybe there are, in other countries, but that has been a very powerful engine of learning for us in the U.S. Really quite something. The federal role in the U.S. has also been large. I was working for the federal government when I first got into mass timber. We did any number of things. The initial motive for the U.S. in getting into mass timber was not sustainable construction. It was not embodied carbon. It was the hazardous fuel condition that we had in the forest in the western states in the U.S., where for 100 years we've had a priority of putting out wildfires. And we're paying the consequences of that now. We have too many trees. And so it's sort of how do we deal with that condition on the landscape? How do we use more of this wood? And we were seeing mass timber as a way for some of that wood to pay its way out. Now, over time, we were acutely aware of embodied carbon and that, but that was not how we went and got the financial support to get into mass timber. The first dollars that I used to initiate the program, it was fire money. We were using fire suppression money to introduce mass timber into the U.S. That's evolved since then. It's mass timber is carrying its own weight right now, so it's things have really progressed. And to give you a sense on some of the big drivers now, because I believe there's a lot more coming. But one of the real hallmark moments in the U.S. was in 2021 with our building codes across the country, where within existing building code in the U.S., you can go up to 18 stories with a mass timber construction. You can go beyond that, as the building in Milwaukee did, by using the provision in the code for alternate means and methods, but right prescribed in the code, you can go up to 18 stories, and that's made it so much easier. We have, I'll just say there are 10 and 12-story buildings that are planned all over the U.S. right now that would not have happened without that 18-story provision being in the code. Also, the Ascent project in Milwaukee, the tall one, I tell people that the most significant thing about that is not the fact that it's a 26-story building, but they just made doing a 10-story building in the U.S. a whole lot easier. Going back to the map that Craig showed, we're also at a point where in every state there have been mass timber projects now. So builders across the country now all know somebody that has done this. And I think that degree of familiarity is a hugely powerful thing. It's one thing when you hear about it, on the other side of the country or in a different country. It's another thing when the guy that you get together with a couple times a year to talk about business has done it. And so I'm expecting us to be doing a whole lot more than we're doing right now. Then you superimpose on that all the awareness that's happening right now with embodied carbon. And I think going forward in the U.S., that will be the big driver, and it will be an enormous driver. We're starting to see embodied carbon legislation at the state levels. There's been legislation that's passed in 3 different states so far, specifically talking about embodied carbon in construction. There's federal legislation that brings up the notion of embodied carbon. There's a lot more federal emphasis on EPDs and life cycle analysis, all of which flows into embodied carbon, all of which will support mass timber greatly. So the context that we have for going forward is truly extraordinary. And in the U.S., the forest resources that we have are truly substantial. So we're adequately positioned to support this growth domestically. We currently import a fair amount of material from Europe, and I have no doubt we will continue to do that. There's also a chain of factories in Canada where I would argue the primary market for those factories in Canada is not Canada, it's the U.S. So yes, we expect more factories in the U.S., but we also expect we will continue importing. It's kind of the big picture. Thank you for having me here. I'm excited to meet some of you individually. And that's it.
Well, we'll have the next speaker, but I want to add, I was really happy that Steve agreed to come, and he's worked for decades with the U.S. Forest Service, so take advantage of his time here to understand how the U.S. federal government supports building with wood. Now, Fabian Scheurer.
World probably doesn't hear me. It's good now? Wonderful. All right. Yeah, thanks, Greg, for the invitation. I'm glad to be here back in Copenhagen after a few years. I'll be showing you very few projects only, and probably give you something to think. This is a project that's currently on the way in Stockholm in Sweden. I'll come to that back later. That's the topping out ceremony that happened just before Christmas. Nicely under a tent, yeah, so it was cold outside and inside also, but it was not raining there. My name is Fabian Scheurer. I founded a company that's called Design to Production about 15 years ago, which does exactly what the name says. It doesn't do any design and it doesn't do any production. It just does the two in the middle. So it translates design into production. And to be able to do that smartly, we also try to sort of inform design about production. So the idea is to connect the two as close as possible. Our claim is that we both talk and speak design and production and simultaneously translate between the two. And the overall aim is to do that on a digital basis. So what we're trying to do is build digital bridges between design and production and connect digital design and digital fabrication. We've been doing this, as I said, for about 15 years. More than 200 projects have come out of this. A lot of them are in timber, as you can see. Maybe some of them will come familiar to you. One of this is the Swatch headquarters in Biel in Switzerland by Shigeru Ban. That was opened a few years ago, 2019. You only see a small part of the building here. It's basically 240 meters long before it takes off, goes over the street, and then rests its head on the other side of the street on another building that's also by Shigeru Ban, which is the Omega Museum, because Swatch and Omega basically are connected as companies. That's the one that I've shown on the title. It's an annex to the Technical Museum in Stockholm. That is currently in build, will be opened hopefully in this year, 2023. Basically hosting a big wooden geodesic dome with a 3D cinema inside, and then you have this timber grid shell on top of it. 1,500 square meters, designed by Elding Oskarsson Architects from Sweden. And this is sort of the things that we're doing. All of the projects that we've been doing are digitally designed and fabricated. All of them are prefabricated off-site, so it's basically big sort of construction kits that we're developing together with the planning teams there. 80% of them are in timber, which is sort of an accident. It wasn't planned like this 15 years ago because we wanted to go into digital fabrication, but it quickly turned out, and we learned that the timber guys are basically far ahead when it comes to digital fabrication. And they're used to prefabrication because they've been doing it for a couple of thousand years, basically detailing all the beams before they hoist them up into the church. And almost all of them are pretty crazy, curvy, freeform projects, except for some. We've quickly jumped into the realm of more orthogonal buildings a couple of years ago. This is a building in Switzerland, in Winterthur, half an hour from Switzerland, called the House Krokodil. It's an 8-story housing block, 250 apartments, completely made in timber. We were working for the timber contractor there in Plenia, and that was sort of a pilot project to find out if we could play all the tricks that we've learned with the crazy curvy things over 15 years, if we could translate that into sort of the standard orthogonal realm. And I have to say, we almost failed. The building's there, it's standing, everything's fine, but it cost us a lot of nerves. And I'll try to explain why. But it also gave us a lot of answers to one question, which is, and that's always posed as, why are you only doing freeform projects? I mean, really 99.99% of the building volume out there is pretty much orthogonal. And you're coming along with all those crazy, curvy Rolls-Royce Formula One projects. Our answer always was, because we can. And it's great fun. And you get invited to conferences and can give talks. But with this one orthogonal project, we actually learned that there's a second level to that. And the second level is actually the non-standard freeform stuff is the low-hanging fruit when it comes to digital revolution in the AEC industry. Because at a building like Swatch, from the first day on, they know it can't be done with the standard things they've been used to. At a building like the Crocodile, if you start trying something new, for sure there's this one day where someone comes along and says, it's always been like that, we've been doing it for 20 years, it's never been like that, and who are you to tell me anyways? Yeah. So why try something new? And this is much easier in this crazy project, because they all know it's not going to work otherwise. So the question is a little bit, we know we have digital fabrication, especially on the timber side. It's already there. Some call it Industry 4.0. And we have digitalization on the planning side. Most of you call it BIM, Building Information Modeling. It should be actually an easy thing to just put the two things together, send the data from the BIM model to the fabricator, and bam, everything just works. In reality, it looks more like this. You have a project, and the knowledge about the project rises very steeply in the beginning and then a little bit slower towards the end, but pretty continuously. People learn about what they want to do, what they want to build. If you look at the digital information in the project, it typically looks like this. After every project stage, you throw away at least 80% of what you've built up. And then you work frantically to rebuild it at least to the level that you have been before and a little bit more than that. And that's pretty common. especially when there's a handover from the planning side to the fabrication side, because people like Greg take your IFC model, look at it, throw it into the bin and start building it again in CAD work or whatever the tool is that they're using. The question is, why is that? Obviously, there is too much information there, and most likely there's too little quality, because otherwise you would just take the thing and use it. Yeah, it's a lot of work building those models. Just to be clear about that, this is not about bashing IFC or whatsoever. It's not about the format the data is in, because IFC is just a wheelbarrow to transport the bits and bytes from A to B. We're talking about a content problem. Yeah, the quality is not right, not the box around it. Give you an example. Challenge number one, if you go into fabrication, you have to have the level of detail that fits what you want to do. In a project like Swatch, there's about 140,000 screws, which all need to be pre-drilled in this curvy structure, because otherwise you wouldn't find the correct place to put them. And they can be, but the question is, how do you define the position of every single of those screws in a digital model before it can be drilled by a digital machine? Because it's not there. If it's not there, the machine doesn't know where to put the drill. So you have an explosion of information that's happening at that point. And it has to be of the right quality in the end for the machine to work with. Our solution to that is that we're using parametrics, the same way as the gentleman from Lindner showed beforehand. Yeah, we're starting with an abstract model that only contains the grid. And then over a few stages, we have little machines there that are not really explained that turn this abstract model into more detailed models. Until in the end, we have all the screws in there. Sounds easy. It's a little bit of work, but it's working. Yeah? That means for a project like Swatch, in the end, we have about 40 gigabytes of data. About 18 gigabytes of that is actually 3D models, what you can see in renderings and other things. A little bit more, actually, more than half is data generated from that goes to fabricators, that goes to approval, 2D drawings, fabrication data, lists, Excel sheets, you name it, it's in there. The actual work is over there. Yeah, it's 12 megabytes of scripts, or Grasshopper in some cases, that does the actual work and generates all this. And this is the lever that we can pull to create a full set of construction documentation for a project like Swatch with 11,000 square meters of timber grid shell and 2,800 facade elements and about 75,000 individual parts in there with 4 persons within a year. Yeah, that's the trick. Problem is, it only works if you have a systematic approach to what you want to build. Because if you want to put that into rules, into parametric rules, all those 470 individual glass elements have to follow the same rules. They're all different, yeah, but I have one button to press to get them detailed. If they all follow different rules, I need 470 buttons, which are much more expensive. And this is how we do planning as of now. Yeah, you have a lot of people individually detailing things. This is not how it works. Yeah. The second challenge that we're facing is, in the end, you're having a CNC machine that is perfectly capable of and actually wants to fabricate within 0.5 millimeter tolerance. How much is that in inches? A 32nd. Yeah, and this is not just because we're in Switzerland and we have a certain fetish for precision and we actually want to be watchmaking. This is because these are structural parts that need to be connected with structural details, and the structural details are fabricated directly on that machine, and there's standards and norms and regulations that tell you that a steel dowel needs to fit into the slotted plate within 0.5 millimeter tolerance, or otherwise it's not going to ticked off by the engineer. So we need that, otherwise it wouldn't be there. Question is, if you look at your standard BIM model, is it precise down to 0.5 millimeter? Or actually, you need more than that because of a little bit of tolerance that's also in the modeling process. You need 0.05 of a millimeter in the model before you can fabricate 0.5 of a millimeter on the machine. Typically, what you get as an input from the planning stages, if you're lucky, about 5 millimeter tolerance. Yeah. And that is also not to bash the architects and the planners. They simply don't know the details at that precision when they are forced to issue that information. So how do you get from a blurry 6B pencil model at the design stage to a crisp and sharp 6H pencil drawing model at the fabrication stage within one model without throwing it away and rebuilding it? That is the big question there. Again here, of course, we're using parametrics. And the thing is, we cannot start with a blurry abstract model to get a crisp and sharp detailed model at the end. We have to start with a crisp and sharp abstract model in the beginning. And this is why we're taking great pain to create very slim and slender but very precise models at the beginning that, for example, show you the building grid where the axes actually meet in one point if they are supposed to, which is never ever the case if you get drawings from an architectural or engineering firm, because it was never asked for. Yeah, in an early stage of a building, you just drop in your axes and they're roughly where they belong, not down to 500th of a millimeter. Why should they? But if you want to build up on that data until the very end, they have to be. So for Swatch, we have a building grid, we have a reference surface that defines the actual shape of the building. We have the beam grid that is precisely defined, all already very early in the project. So we entered the project 2013, 2014, 2015, we had that reference geometry. 2019, we had it detailed down to production data for 75,000 parts. If you don't start over there with a good model, you will not end with a good model on the other side. Shit in, shit out. Yeah? And the challenge number 3 is you have prefabrication. So in the end, everything needs to fit together. And you have not two small parts. This is one of the smaller parts dangling on the crane over there. It's about 2 meters long. The longest part is about 16 meters long, coming out of the same machine. And they all need to fit. But once they're hanging on the crane, it's darn hard to change them anymore. Yeah? You cannot make it fit on site. Either it fits or you have a problem. The question is, a lot of the processes we're working in the building industry are following this waterfall model. Yeah? Whatever the process stages are called from left to right over time, doesn't matter. You start at the very top topic there and you gradually dig down until you end up with thinking about fabrication and assembly 5 years into the project. Problem is, it doesn't make sense to fabricate anything that you cannot assemble, and it doesn't make sense to assemble it, to design anything that you cannot produce in the end. But when do you find out? Too late, typically. Yeah? And this is where design for manufacturing and assembly comes in, a term that we actually stole from the product design industry because those are our heroes here. Funnily enough, Swatch was one of our role models before we worked on the Swatch project, because this little watch over there that you all know managed to save the Swatch, the Swiss watchmaking industry in the 1980s because it was cheap, cheaper than the competitors from Japan. Why was it cheap? Because it only contained half of the parts that an average watch of that type contained at that time. 52 altogether. The other 50 parts were embedded into the plastic housing. That was then for the first time possible to create with the respective machinery there. So they basically just rationalized the parts in there. They only had half the parts to assemble. Even with high Swiss wages, it was still cheaper to put that thing together. The other role model that we have is not smart parts, but smart details. This is a famous Swedish shelf that you all know. It's been in production for 50 years almost. It hasn't changed on the outside, except for some new colors. It's still 60 or 80 centimeters wide, 2 meters high, 30 centimeters deep, whatever. But if you happen to have assembled some of those over the last years, you have probably noticed that the detailing has changed. They have constantly evolved the little nuts and bolts there to make it possible for stupid people like me and you to put this thing together error-free. Because otherwise, they have a hotline somewhere in Stockholm that you call and say, this is bloody shit, I can't put it together. Take it back, I want my money. Yeah? At one point, for example, the drilling, the diameters of the holes for the dowels and the steel parts that you have to put in started to have different diameters, because then you couldn't mix them up anymore, which would make the thing not fit together in the end. Yeah. So smart parts, smart detailing, foolproof. But that also means you have to start thinking about interfaces. If you think in modules like we have them here, you have facade elements, 2,800, they're all different, 10 different parts, different types, onto that facade. And you start planning this, and then you hand it off to the two different fabricators, the timber fabricator and the facade fabricator. The last time when you have this model in your hands before they start dealing with it and building their fabrication models out of it is before that. So what do? You create sort of an interface model that says, this is a hull volume of the facade element that you have. Yeah, as long as you are staying within that volume, dear facade contractor, you can detail whatever you want, we don't care. The thing needs to work in the end. It's like in software engineering. You talk about interfaces and the black box. Yeah? As soon as you stick your finger out of that hull volume, dear facade engineers, you better call the timber guys beforehand, because they might be coming along with the chainsaw, and then your finger is off. Yeah? And the interface is exactly here for both sides, so you know where to look. Yeah? So the question is, and that's a slide that all of you have seen if you were in any BIM talk ever, yeah? It's okay, we have a traditional design process where a lot of the work is happening just before fabrication. And wouldn't it be a great idea to basically build a digital twin of our building so we can find all the mistakes and the errors that happen half a year before that, while we're still in the design stage, so that we don't find them only on site. Great idea, I would also say so. The question is, how is the work underneath those two heaps actually happening? Currently, it's basically the same thing just half a year earlier, which means we're in the same deep shit half a year earlier than we've had before. Because a lot of what we're doing when we do build digital twins is actually the same as we did when we build buildings. We pour a lot of information on a big heap without caring too much what's in there. Yeah? And what doesn't fit is made fit. And never ever does someone actually zoom out and find out where the problem is and then solve it at the root. It's just cut off. And this is why the models end up like we have them now. You look at them, throw them away. Greg starts CAD work and does a new model. Yeah? So the question is, if we are digitalizing, we should listen to that guy who's the CEO of Telefonica, who gave an interview in 2016 and said the very interesting sentence, when you digitalize a shitty process, what you get is a shitty digitalized process. And we need to think about the processes. And we need to think about, if we want to industrialize building and fabrication, we also need to think about how do we industrialize the planning process in front of it. Because this is craftsmanship at the moment, not industry. Yeah? And how do we scale it up? Because we don't have the people to deliver all that data to all the machines that we need to build all the houses. And it's probably not going to work like that. Yeah, you just get a few new desks and more computers. You have to think about the process in there. And you probably have to think about things from the back end, which means we're always talking about pull planning when it comes to moving items. So the last one in the chain actually defines when do I need this wall element on site, and then everything goes forward until someone realizes, I have to build it now so that I will end up in the right place. In planning, we're still doing push. Someone's doing a model and then it's being pushed down the pipeline because we think he will need that information. In the end, no one's ever asking him what he actually wants. So we need to be caring about the back end of this thing and ask, what type of information do you actually want to use for your fabrication? And then create exactly that and nothing else. That would be an industrial process. So I think we should start talking to each other, design and production. And if you're afraid of that, you can talk to me because I can translate. In the end, we can do things like that. We could also do them rectangular, if everybody would listen. Quote from William Gibson I like very much. The future is already here. It's just unevenly distributed. Thank you very much. Voilà.
Oh yeah, okay. How's that? Are we good? Yeah, good. So this is essentially the basis of my provocation. What I'm interested in talking to you about is adaptive transformation. Please bear with me. I have 100 slides to get through in 10 minutes, so that's 6 seconds a slide. So it's going to go fairly fast. And one of the reasons is because I've interjected my own talk with another talk. Simply because we're actually also working with Implenia in Winterthur on what should be the world's tallest mass timber building, which is called Rocket, out of the Rocket and Tigelles, which is a kind of little area. And we try to see this as the kind of anti-tower, the sort of tower that does more for the ground floor and the space around it than what a tower is usually critiqued for doing in the first place. But of course we have the relationship between mass timber and facades is very important because of course it's not typically fire on this scale of timber that is the problem, it's moisture. And we have to design in a way that is both flexible over time but also a way that allows you enough sort of control and play over the elements. So it's also interesting to note that this tower is unlike all of the other so-called mass timber towers insofar as the load-bearing structure, the core and the shell, they're all made of laminated veneer lumber. So it's actually a vertical load-bearing structure, which is also mass timber, and I'll get into that in a bit. But the ability to then fold that core, which is here, the floor plates which span between the cores and the outer grid structure, they're actually working as two tubes, one against another, and it's this relationship between those two tubes that makes the structure robust, especially in seismic zones, for example. And then, of course, the facade on top of that. I guess the cleverness in the architectural design was based on where you actually organize the vertical surfaces so that in the way that we plan the building, we can make these changes and flips, which not only creates play in the facade, but it allows you to have this sort of ability to change spatially over time. And then another sort of innovation behind that, which I'll get back to later in this discussion, is the question, well, okay, mass timber is expensive or seems to be expensive to the industry. How do you relate that back to actual value, return on investment? How do you build a business case around it? And so we've built a kind of system that allows you to look at the design variations of what could possibly be built, analyze them on a series of baseline volumetric and sometimes like floor plate analytics, and work out even where things change in value over time, how you could create a building return on investment which takes in the design and materiality of the project, but also the let's say the design decisions, what you're putting where in the space, and also especially looking at design for adaptability or transformation over time, because we know the world is shifting in terms of its demands, and buildings get demolished not for the fact that they are not able to stand up anymore, but because of market forces. So to avoid this kind of thing, and of course a general collapse in the economy is almost symbolized by the general collapse of a building. So just looking into embodied carbon, of course, it's the relationship between it and its typical concrete counterpart is represented here in terms of proportionality. And of course, it's because there is embodied carbon, sequestered carbon in the timber, it allows us to see this like overall drop beyond the baseline goals of RIBA sustainable outcomes. Just looking, I have to shout out to Andrea Frangi, who's the chief engineer behind this and researcher and professor at ETH. And they've done a lot of work to look at how these binding systems can work so that the internal core and the external frame are able to work against each other. And they have to, of course, bear moment because shear force is carried by these two layers as well. There's a typical question about impact, vibration, flanking, that sort of thing in the acoustic realm, and that's also being studied. And part of the answer to that is the composition of the floors, which are both using concrete overlay on top as a compression article and timber on the bottom, which creates this stiffness. But actually, as you can see, when you apply massive forces such as seismic forces, there's a lot of toughness and flexibility in the system as well. A typical question is always about fire, and of course in this case Andrea is talking about the idea of charring becoming a protective layer, which I guess in this room you're all quite familiar with. He was also saying that you're able to rebuild that structural surface after a fire, so it's not a death knell to the structure of a building to have a fire. It can be rebuilt in layers to re-establish that capacity. So that's like really quick, but I just thought I'd put that out there because it's a mass timber event. But my main provocation is actually about adaptive transformation and the potential of mass timber in this realm. And I think we have a lot to talk about because I think you've got a lot of skills that we could possibly use. But what am I talking about, first of all, in terms of adaptive transformation? A lot of people talk about renovation or adaptive reuse, and we find the most difficult area and the one that has the most potential is actually when there's a typological change. When a building has served its useful life in one typology and can't be renovated, what then happens to that building? Does it get demolished? And so we have these sort of tropes in architecture that we talk about, like surgery, for example. If something was wrong with me, would you demolish me and start again? I hope not. So then there's the question, how do you treat a building in terms of the subtractions or additions that can be made? And how does that relate to the terms of risk versus reward? Well, in many building cases, the adaptive reuse or the adaptive transformations that have been done have more or less been applied to buildings that have some heritage overlay, where there's no choice but to transform. But what we're interested in is the typological standard, the boring buildings, the unimportant buildings, because that usually represents the majority of the market. So how do you take these boring buildings and start to use their native properties to create something that has a design value that is better than what you would have if you had a blank slate? And of course, if you were able to read that quote, our obligations as architects and designers are to understand what qualities exist that we can leverage upon. So there's many different ways of doing it, and I'm continuing with the sort of medical surgery trope. But in this building here, it's interesting because this was a mechanical issue. It wasn't necessarily a structural issue. It's a library where the mechanical services were not fit to work between the floor to ceiling heights, and we plugged in this separate mechanical building to allow it to continue as life as a library, but we also used it to supplement the spaces that were not possible inside. It's a kind of life support system approach. And to get back down to Greg's favorite topic, what is this really about? Well, there are some fantastic and irreplaceable features of mass timber that are hard to supplement with others. Of course, there's steel, which is also lightweight, but there's a range of factors that I think it's going to be more interesting for mass timber than a steel product in the same circumstance. And I'll talk through that in a little bit. So why adaptive transformation? Well, because of this. Because the first insight that we could talk about is that there are dying typologies. It's not just that there are shifts in the building industry, but they're actually affecting, especially in America, Seattle, San Francisco, and north in Canada, and Calgary and Edmonton. Office buildings are starting to become obsolete. One of the background reasons for this is, of course, COVID, but another one is that there's this situation where global economics took a turn. And this is a picture that I quite like because it's quite clear that there's only one person in the room who has no idea what's going on. But it was the point at which Bill Clinton signed away the Glass-Steagall Act, which was a restriction on banks to essentially invent money. And this creates this exacerbation, if you like, of the boom-bust cycle in architecture and building industry and design global economics generally. So this is a graph that pretty much talks about how every tallest building in the world was either built just preceding or during a major economic crisis, a symbol of the sort of boom-bust economy that we're experiencing in greater amplitudes now. So for that, you know, what's the relationship between macroeconomics and lifespan dropping in buildings? Well, part of that is the idea that risk is being divested from the industrial sector onto individuals. We have more, in America this year, we have more freelancers than paid professionals, full-time contracted professionals, and the inability for companies to lease over the long term, or the needs of flexibility around the workforce, mean that there is dropping lease length and more pressure on the market to change the way that the architecture performs according to the market demands. And so you've got the situation now where the average building now lasts 50 years, commercial building, and is engineered to last 500 years. Maintenance included, of course. And that's reflecting, that relationship is reflecting on whole cities and whole typologies. So many situations occur now where it becomes unreasonable to even build a certain typology in certain spaces anymore. And of course, what does that relationship have to do with embodied carbon? As a lifespan shortens, the proportion of embodied carbon goes up. So again, back to mass timber, if you're building with lower embodied carbon, that's a general plus. But if you can save a building's lifespan, it's even better. And it's not just carbon. It's really the environmental catastrophe that's being created by the building industry is partly due to physical waste and the extractive nature of what building new is in the first place, where the money is being put into extraction rather than local labor. And I'll look into that a little bit further. So how might we establish an assessment toolkit to determine how existing building types might convert? Okay, so that's task number one for you guys, any of you guys who are attending the hackathon over this weekend. What we want to do is mirror the concept of material circularity in the building system. So to go from utilizing better to maintaining and repairing, and the first step is transformation before you harvest materials, before you recycle, and before you burn for energy. And the last two steps are what we're focused in most on the industry right now. So the design assessment toolkit, as a provocation, might look at the idea of fitness analysis. How might any building convert to another typology regardless of what that typology is? How do you feed the understanding of an AI so that when you present a building, it can give you a fitness test against different typological outcomes which are a change from its current state? And can that create a playbook? So that's something that we're working on at Henning Larsen as a research approach. Insight number two, transformation is becoming more desirable politically especially, but the business case is difficult to quantify. And that's because actually we're not very good as an industry at understanding what the cost of transformation are going to be. And I'll look into that in a second. But starting with the political desirability, if we understand that UNEP are saying, okay, by 2050, 80% of the buildings that are going to be there in 2050 are already built, then we have a real issue about how we even deal with, let's say, operating carbon, how buildings actually perform. So if you say 20% are built until 2050 new, it only really represents a fraction of the operating carbon because of the increase in performance goals of building codes. So if we were to reduce this by 50%, that really only leads to a small gain on the overall story of the way a city performs. Whereas if we instead improve the existing buildings by 50%, that's a massive win for the city, right? So, come on. So in that case, you know, it was unaware, the politicians were completely unaware of this situation maybe 5 years ago, and now it's the hottest topic, and it's why WLCA is coming in as a real focus, and it's starting to influence the building code. And there are now many areas like Brussels, parts of Norway, parts of Denmark, that are looking to give incentives for adaptive transformation. So how do we then create a better picture of risks and returns? Because if it's about risk, then our job as an industry is how do we tackle that comparative difference in risk of new build versus transformation? And part of that is based on an understanding of what an ROI is and how it's predicted even before a brief comes out. Normally, a developer or a funder, let's say, would go to a real estate agent and they would say, well, how much per square meter would I get for this typology in location A? And that's the basis of return on investment is the basis of investment. But what is missing here in this relationship between real estate consultants and investment, how much could I get, can you do it, yes or no, is actually design. And when we look at the idea of getting into the strategic level of modeling options, then we can start to build design quality into the ROI features of the into the funding of the design process itself, and how much you're willing to invest in the design of the transformation, what you're going to do. So what we're trying to do is build a system whereby this relationship between design quality and return on investment is clear to the investors. And finally, how to make transformation more attractive than demolition and rebuild. And so the second last insight, is that the building industry is educated for new build, but this creates an uneven playing field. And let's say you want to, demolish and build something self-similar in terms of the amount of square meters that you put in place, versus maybe transforming it. So you consider a standard office tower. Well, first of all, you could say, okay, most of the structure is there, most of the materials there, it should be cheaper. But then you get the situation that in our industry, it's very hard to estimate construction labor, time, and cost, and these sorts of overruns that occur on site. Because we're using, in new build, we're going from the ground up using highly CAD, let's say BIM-influenced scheduling systems and very clear methods of construction. And we're back in the mid-1900s where everybody goes in with their bits of concrete and drywall and everything's done very manually in that process. So it's very hard to estimate. And labor availability and costs go up and down. So if your margin of error ever supplants the profit margin, even if you should be able to make more money in this situation, you'll go for this. So how do we do this? How do we reduce the margin of error in transformation? And I would say, okay, on top of that, as you've seen, how do you look at the design modeling situation and look at that in terms of ROI in the first place, what you could actually predict to get back in return for your investment? So this relates to modeling. How do we create tools that help us model the costs of transformation? And so when you look into what is the basis of a cost, the basis of the cost basis of a building, you can see that, of course, there is material cost and labor cost in both, but the proportion is more or less flipped. We understand that in transformation, the majority of the cost is in labor. But because we don't utilize off-site manufacture, because we don't have any systems in architectural design of actually modeling the process to deal with existing structures, then we don't have this ability to reduce the labor component of a transformation, and that's what we're working on at the moment. That's what we believe we can build to transform the market, because not only does it create a difference in profitability, but it also creates more of a narrow risk profile, which is the thing that is holding back transformation right now. So 3 parts need to be connected together: scan to BIM, construction simulation, and offsite manufacture for transformation. And that's why I want to talk to you. So in order to move forward with adaptive transformation, it's actually these 3 parts that we could tackle separately or together, but any win in any of these parts will make a sea change in the outcome of buildings demolished and saved. So this is the thing that I'm not going to explain, but how we're working through the process. And finally, the case for mass timber, which is the part you've been waiting for all this time. It's finally here. And that's simply this, and it's no more than this slide, really. It's the idea that there's a potential for mass customization, not just with big manufacturers, but with small manufacturers. There's the lightness and handling which make timber something which is unparalleled in a way, which is why perhaps you do your tricky stuff in timber. And thirdly, it's the concern of adaptability. If you're using mass timber, then it has very workable methods of being readapted in future when the market shifts again and the change has to be made once again. So here's a project that we recently won. We haven't started building it yet, but it's on its way. And it starts with the notion that we were given a site where the client really wanted us to tear the whole thing down and build 2 towers. And we said, okay, but actually one of them doesn't have very good structural basis for this kind of volume, and another one does. And despite the fact that the client hated this building more, we managed to save it. So we start with the adaptation. We add mass timber, and the interesting thing is it's not just building on top, but building within, and that requires a scan to BIM process where you really know your relationships between existing and future geometries. Then there's the idea that, okay, this side was also closer to bedrock, so we're reusing the materials there and going to the 3rd level of circularity on that side and the 2nd level of circularity on that side. And the notion that we kind of save the facade existing facade by adapting it and mirroring it, if you like, in the facade that the client actually did like. So just a transformation there rather than a total rip out and reinstall. And you can see that when you use mass timber, even if you're creating more space, you get an experiential quality that you wouldn't otherwise have with a standard construction system. Material reuse, and final slide. And that's it. If you are interested in getting in touch, that will go straight into your phone as a contact, and then you can contact me. Thank you.
Thank you. That made my trip worth it, just those presentations already. I hope you liked them. My job will be to get that message out to more people. Here's the bad news. Our next speaker, that half-hour break you were supposed to have, that's not going to happen. Feel free to go because I have Helena Lidelau from Volumetric Building Companies. She's presenting remotely. She's scheduled to start about 1 minute from now. So please stand up, take a quick break, but I think because she's remote, she'll want to start quite soon. And then do stick around. We'll have an interactive panel discussion. Then we'll have another hour for networking. So take a quick break, but she'll start soon. Thank you.
on.
Now is it working? No. Let's check. Okay, which one's working? Is it working now? Yep. Okay. There we go. Thanks for coming back in. Helena just got off an airplane 15 minutes ago, but it does look like she's ready. So Helena Lidl will presenting here. Her PowerPoint or her presentation will be here. I was really hoping Helena would, she just gave a keynote at the Industrialized Construction Forum in Stanford, and I begged her to come here. She kindly said, well, look, I'll be on an airplane, but I will share the presentation now. And I think she's unique that she's working at volumetric building companies in the US as the CTO, an amazing company, and she can offer that unique perspective of what is it like to go from a leadership in Sweden to a very much high prominent leadership position in the US. Helena, is the sound working?
I think I can hear you really well. Can you hear me?
I can hear you fine. Please begin.
Thank you. How do I advance the PowerPoint? Do I just tell you?
Just a moment, I'll check. Yes. Yeah, we're on the first slide, your introductory slide.
Thank you. So I have some airport sounds in the background. I just let her finish and then we can go. Or are you okay with me like this?
We're happy to do so, even if we have the background noise, if you could just continue.
I will. All right, so Sweden. Well, someone claimed, officially, not me, that Sweden is the #1 in innovation in the EU a few weeks ago. And the reason for that is the culture that we've built over the years. So I brought this as an example of what Swedish and I also think Danish design would look like. Utilitarian, functional, inclusive design, much created to serve everyone, and also a very balanced approach to using natural resources in wood and steel. And this was the contrast with the design that I see happening on the US and American continent. So you can take the next slide, please. So what happened really between the two worlds here, Europe and Sweden specifically, and the US, is that US actually made a few significant inventions that we benefit from today in industrialized construction. So the US was the first ones to organize dimensional lumber and machine-made nails, which were a big part of the boomtown expansion during the exploration of the West in the 1800s. Now we went over to the US and learned from them about cookie cutter designs, and the first house factories that were built here in Sweden and adjacent countries too in the 1920s. Now the US, they built the first modular home ever built in 1929, and that led to the big development in the US around manufactured homes, where a more common word is the trailer parks or the trailer homes, and it's not considered a very good place to live right now. And they are constructed with pretty poor technique. So a alignment with modular in the US is really a stigma for the industry there. We went over there and looked at their factory structure, came home and started building modular and panel factories, but never went towards the manufactured homes. So this method became a way for Sweden and many other countries in Europe to solve the housing crisis that resided after World War in the 60s. US had a similar program that was called Operation Breakthrough. It resulted in a lot of prototypes, but it had no long-lasting effect on the industrialized construction industry. Approximately 3 to 5% penetration as we speak right now. And the other, on the other hand, in Sweden, this Million Homes program, there was a direct parallel to Operation Breakthrough, resulted in an industry with 70 plus factories, mechanized and automated, and a penetration of industrialized construction of 45%. So the development in these two countries has been similar, but very different still. The outcome is appallingly different. So you can take the next slide, please. So I worked here for 12 years, Lindbäcks Bygg, which is a company in the northern part of Sweden, where we produced, and they are still producing, multi-story, multi-family homes using modular technology. This is a snapshot from the factory, and it's available on the internet if you want to download for yourself at some point. You can see that the structure in this facility is clearly inspired by the manufacturing industry at large. So on your far left is the modular assembly line. In between there is a walkway for people to work. The next line over is your materials, and the big aisle you see in the central part of the picture is for the forklift. This is exactly what you would find if you were to enter an automotive factory. The degree of automation in this facility is one of the highest available on the European continent. There are other facilities, for example, in Estonia, Germany, and Netherlands, who are at par. But at the time, we had a very good success with this factory. It opened in late December 2017. And apart from being a very tangible and practical flow here that's easy to understand, it also has a digital backbone with digital drawings and machine files distributed to each station through an MES system. So the next one, please. So of course we tried to move the needle towards manufacturing here, and this facility was organized around a lot of prefabrication ideas that you either see or hear in different places today. We used plumbing trees, we used the wire harnesses for electrical installations, pre-cut wood, pre-cut sheathing, bathroom pods, and kitchen kits were all applied in this facility. And you can take the next one, please. And we also created a subsidiary company that made the bathroom pods to keep up with our flow. The prevalent material that you use in Sweden to complete a bathroom is tile, both for the floors and the walls. And the curing time for tiling is not something that you want to have inside your assembly line because you simply can't wait that long. So we separated that out as a separate business, and they still run. And the entire organization for them was driven by a takt time in the main plant of 30 minutes, which was the plan all along for this facility to be able to output one module every 30 minutes. And this is a glass fiber composite pod that was created. So it is lightweight and moisture proof all the way through. Next one, please. So this is where I was taught myself through working with the development of the facility, the method of the 4 M's, materials, machines, methods, and manpower. And now you have to look at all these 4 M's at every station in the facility when you're developing your workflow. So there is a sort of science behind developing and standing up a facility that I now can employ when I come to working in the US. So the next slide, please. And the results are always interesting to talk about. At the peak, we produced a 37-minute takt time, which then requires everyone, both in design and in prep and with machine files and materials and everything, to adhere to that 37-minute takt time. So we had stand-up meetings every morning. We had constant communication between the shop floor and the design department. I was the one who led the design department at the time, and the gentleman on the picture, Henrik Hauptmann, was the factory manager. So we had many interactions during those days. And the results in terms of recognition, the Wallline team was nominated to the Lean Forward Prize in 2021. And this is not the Lean Construction Prize, this is the overall Lean Prize for all industries. So they were very proud to be part of that category. We had visitors coming in from New Zealand, USA, Canada, Germany, Norway, Finland, UK, Australia, China, and just asking us, what have you done? How did you do it? How did you come up with this? And it was a very interesting time to be part of Lindbeck's. We had a lot of digital tools that were developed for daily huddles, visual planning, because we were running this with a lean strategy. And many of the words I use are still from this experience. And we also grew our suppliers underneath it. So our window supplier, our balcony supplier, our supplier for digital tools, we all had a very close relationship with them and pushed them to new limits. And I think that was very valuable because that network that was created during that time was an expansion of what was possible at the time. So this was really something that became good for the industry, not only for Lindbeck's, but also for the other companies on the Swedish market. Next one, please. So we have to forget, or never to forget, that construction exists in a context. So the easiest way, if you flip to the next slide, please, to kill a company is to actually do something that cannot be done in the facility. So I illustrate this by, and I need you to click 3 times now. I illustrate this by 3 curves. So first one would be our market price, which is the black one. And then the cost will come in 3 different colors. So 1 click, please. So traditional construction is always trying to hit a certain margin for the job, and they adjust their different types of methods and their resources to be able to do that. So if you click once more, when you go to an industrialized construction and have a fully standardized platform, which is the perception that many has that you have to be fully standardized, and that is not true. But if you go that route, you have to hit the optimum for that platform to be profitable in almost every job you take on. So you see the belly of this curve here. It has a very clear optimum for margin, and then it decreases pretty quickly. So if you start introducing changes into your production flow, it will eat cost pretty fast. And another click, please. So the cost of an adapt-to-order platform where you can be a little lenient, a little bit of flexibility into it is probably a better way to go if your potential market share isn't really that large. And Sweden is a small market. Sweden is only 10 million people. We never exported outside of Sweden. It's comparable to the US state of New Hampshire. In size and number of people. That means that it's a pretty limited market space that you can have for a platform. Thus, it becomes very important to be flexible However, if you go to the US and the market share and market is larger, you would be able to standardize to a higher degree. You could click once more, please. And these are the arguments that goes on inside the factory, and between the factory and the sales, and between the factory and design. And this is not only from my own companies where I worked, it's also from others that I have been working with. So sales will tell you, we have to take this project or we can't fill the factory. And then, well, what do you do in production? Well, you kind of roll over on the back. But in production, this is how they sound. You can't manufacture this project. Design really has to understand that. And then design gets the blame for something maybe they didn't do, or maybe they did. Who knows? And the last statement would be that those sales guys don't have a clue. They sell whatever, and then we in the factory have to solve it. So the easiest way to kill a manufacturing operation like the one you just saw is to give it a stream, maybe 3 or 4 of non-suitable projects, which is the upper half of the diagram you have here on the left. And the only 2 measures you can do at that point is either you decrease your standardization in production, or you increase your flexibility in the product. Those are the 2 measures you can have, and you have to make that decision within the project. So click, please, and click again, and again, please. And we're done with this one. Thank you. Click again. So there is an ecosystem resulting from all these efforts for industrialized construction in Sweden. That is, I have learned now, world class. While I was working in it, I didn't really recognize that was the fact. So we have a whole bunch of machine suppliers, software developers, logistics people, engineering, and product developers that actually know how to handle this industry. And that is an asset that I believe Sweden as an ecosystem doesn't really recognize that we have as an asset, and that we could capitalize on this. So once I understood that this is probably the case, it became easier to move to a new setting. So click, please. And another click. So this is where I work now, vertically integrated operations. VBC is very much similar to a Lindbäcks, a Moelven, a BLOXHUB that you would find on the Swedish market. Multifamily, headquartered in Philadelphia, and erected the largest modular structure on the east coast of the US in Philadelphia. And now we operate the former Keynotes facility in Tracy and the former Deluxe facility in Berwick. We also have the former Polkom facility in Poland, which is where I come from right now. So click, please. And the factory in Berwick represents the American average, I would say. It's a platform frame where you start to frame out the floor, you set it down as a base, and then everything is brought to that floor. And you build your module on top of it using regular tools and hoists. Your carpenters and all the other skilled tradesmen come up to the module and complete it on site. The double loaded corridor is the prevalent concept, which is 2 modules with a corridor in between. So this is a long module. Of course, we use the imperial system, so 70 feet would be something that we would claim as the length of this, which is around 18 meters. So you understand that to hoist and ship this is not an easy deal. And there is a rule, there's a law in place that states that you cannot ship anything that's disintegrated on US roads. It has to be one integral load. That is why these are built together. And for a European, knowing the roads and how the turns look here, this is not an option to do. So that's my first observation when I came over, and that's why guys, what are we doing here? So you can click, please. Now the factory in Tracy. This is Catera's former facility, or one of Catera's former facilities, I should say. VBC bought that when Catera went bankrupt in 2021, and we have restructured this to become a modular facility during 2022. And this has been a project that I've been involved in the entire last year. So we brought some Scandinavian tech into the facility here, Swedish and Finnish machine suppliers. We reused some of the stuff that Catera had and have ramped it to work better than it did during Catera days. They didn't really understand how to take care of the machinery, so there was a lot of bug fixes and other errors specifically in the software and the machinery that we had to take care of. We have constructed this flow as panels that are assembled into modules. So different from the Berwick situation, this is now a fishbone flow where we have different elements produced first and then assembled into modules. And if you click once more, I can show you the flow. So this is what it looked like when Catera operated the facility. Everything you see here, apart from the orange boxes on your bottom, is machinery. So there wasn't much space here for any material handling or storage that had to be done outside. And it's actually snowing in California this week, so I am not really interested in having my wood and whatnot sitting outside for use in a factory. So if you click once more, this is what we did. We removed all that equipment, and if you click once more, the blue arrows are now machinery. So there is a floor line. There will be 2 wall lines, a ceiling line, where we do flat panels first, and after we made them, we assemble them into modules. And another click, please. This area where the yellow arrows reside is now reserved for materials. So I can store 2 weeks of production, probably more, I have discovered after I made this diagram, in the facility now. And that's very much needed with the latest years of volatility in the supply chain. So please click again. And this is the movie clip that I hope now translated to you guys. So if you can try to start, I will do a voiceover. So this is the floor line, and the floor line is constructed the way you would find it in any Scandinavian factory. And this is something that has been very fascinating for my US colleagues, that we are not hoisting the entire module up and working on the other side, but we are flipping the floor and working on the other side. This has never seen on the American continent, it appears. So I'm very happy that that was the thing. This is so common for me. So this is the wall line, and this is a heritage from Catera. It's a Randic line, comes from Sweden, and I was very happy when I entered the floor and saw that this was sitting here because I know how this works. So that was really, really interesting. We made a new ceiling line where we stand up the ceiling midway. So here is a stand where we flip the ceiling up, and now we can mud sand the ceiling before it becomes a module. And the last portion of all of this is the assembly line, where we have a rolling track, and you can see the modules being completed from start to finish. We do not, as in Berwick, have the modules standing lengthwise. They are on the short end instead, and I don't produce them as double-loaded corridors. These are single ones with a separate corridor instead. Now they're easier to handle, easier to move inside the factory, and it also becomes a visual flow that everyone understands. Perfect, happy that that worked. So last click and last slide. is the digital information. So we are, I said we were vertically integrated at VBC. They're running the VBC studio, who runs on Revit. And Revit has been amended with a Dynamo script to create quantity takeoffs from the architectural model. Now, I also introduced the Finnish software Vertex here to create the structural shop drawings and machine files, because Revit doesn't really speak machine language, and that needs to happen, otherwise the automation doesn't run. And that was a novelty to most of people I met over in the US, apart from the people we rehired from Kitera. They knew what this was and how important it was. With these two tools, I can have full 3D coordination between models, and we use the IFC format for that coordination. Result is presented here on the right. We had a very good experience with introducing digital drawings on the shop floor. When I worked at Lindbeck's, that took 3 years. When I came over here to BBC, it took 3 months for them to adhere to that. And I think the closeness to Silicon Valley really helped here. The former Kitera facility that I work from sits in Tracy, and Tracy is 1.5 hours from San Francisco, where all this digital jazz is happening, and people have enormous ideas, and that is being prevalent also in the culture in California, that everything is possible. So design automation is another part that I really was surprised to learn that US colleagues often look at design as being, let's create a model and then we sit down and do manual sheeting, which means you sit down and you take your views and you create drawing by clicking. And design automation for me means let's create the model and then push 2 buttons and all the drawings are spit out from that model automatically. And that has been difficult to actually pedagogically explain that that is the way to go. You don't have to control every sheet. I think that's those cultural barriers I did not know before I came over. So it's been an interesting journey there. And click please, I think, for the final slide, which is tack. And I end with my kids and my granddaughter now. And I'm doing my best to entice them to enter this industry. So I succeeded with my son. He's working with me, and he's a digital person, so he's in that work stream. And just got a picture the other day from my granddaughter standing with protective hearing aids and casting concrete in the basement of their house. So happy to be part of that too. So thank you everyone for listening, and sorry for being a little bit late and unorganized here.
Helena, can you hear me? From
Yes.
a top-down view, that was why I was excited, because you're seeing all of those differences between the US, and we're seeing how little automation we have, yet that great eagerness in Silicon Valley that anything is possible. From a view even above VBC, do you think there are many business opportunities in more exchange between Nordics and people like you and the US market?
I do actually, because I have really appreciated the advance that I see that Europe as a continent has here. We have a lot of assets that just don't exist. If I want to buy a router to route massive timber walls, CLT, I bet you that in 70% of the cases it will come from Germany. If I want to buy a wall line to produce panels automatically, it will come from Germany or Sweden or Finland. It will not be a US product. They simply do not exist on the American continent, these items. And for that reason, I don't have the accessibility to people either who can run these things. So I actually import people from Europe too. So yes, there are great possibilities.
Then I want to ask you the most American of questions. We saw the $3 billion Katerra failure, also in mass timber in Washington State, where I'm from. But now, with all of the demand for housing and efficiency, and you just reach consistent production, how fast can you scale? I mean, if you have unlimited demand for housing, you're figuring it out. The capital markets have effective nearly unlimited capital. So the constraint isn't demand, it's how fast you can scale your system.
Yeah, correct. That is a very good question. I think the difficulty to scale this is now not how does the factory layout look, because we kind of know how to crack that case. There are enough examples in Europe to understand that. It sits on the people skill side, and it isn't then carpenters. It is how do you operate such a facility. So you then have to hunt for people in manufacturing rather than hunt for people in construction. So that's one limiting factor. The other limiting factor is the availability and lead time to organize this type of equipment if you want to go for that, the first step. And then you would have to turn to Europe as your supplier. We've been fortunate enough to have this within a year. But I will also tell you that it's very wise here to have a phased approach. So you start manual and you infuse machinery as you go, and then you can teach at the same time as you ramp up. So strategy-wise, when you open this facility, I would never have done what Katerra did, which was buy a bunch of machinery, throw it in the factory, and tell people basically just go figure it out.
Well, yeah, but that's such an American approach.
No. I know.
Anyway, no.
I'm happy to be European.
No, yeah, I'm happy you are. No, thank you for your time. I have more questions. When your presentation from the Industrialized Construction Forum becomes available, I'll share that widely. And I hope you make time to present. I know you are busy again, so we have more resources telling your very compelling story.
Thank you. Well, thank you for having me. It was great to be here.
Thank you. And I think 99% of everything you're saying applies directly to mass timber as well.
Perfect. Thank you. That was good. I was a little afraid of that one.
All right. Okay. Thank you for your time, and I'll be in touch.
Thank you. Bye now.
Wow. That was perfect. Thanks. I think now if we can have the presenters that were up come up, and we'll kind of have an interactive panel discussion. But after what Helena said, wow, the timing worked out, I think, where she left just how little automation or prefab we have in the current existing market, yet how much potential is there, and how much we do need the Europeans. I have the same thing. That's why I have a Swiss business partner. It's like, well, we don't have the machines, so we have to use them. The software is all coming from Europe too for the mass timber, and that's in the majority of all the factories. And the argument I'm always making, Americans like to raise a lot of money and build a building and fill it full of really expensive machines that take a year or two to show up. And then like, well, we'll figure out how to run it. We'll just go find those people after we're done that, after we've sold a few thousand buildings. Obviously, that's kind of a recipe that won't work out. And we're seeing a lot more of that, even in mass timber right now. So on one hand, there's all the potential in the world. And at the same time, a lot of companies are repeating the same mistake. Missed opportunity. Anyway, that's only my opinion. I think if maybe we should sit there. Is that all right? And then we didn't take time really to ask questions. I'm sure people have a lot of questions. And then one of the topics I do want to address is, wow, based on all of these conversations, what we're all learning, what ideas do you have? Like, how should the US and European people working at the forefront, like all of you are, is it even of interest? Do you want to, if you're busy enough here, there's plenty of work here, and you're locally connected, you're supplied, is it worthwhile even trying to make those connections across to the US? Or is it focused, like I think Fabian was saying earlier today, the mass timber companies, many of them he knows, they're booked out for a year or two. So why are they going to bother or assume the risk to even care what's going on in a distant market like the US? posing that question, but here, I guess who do we want to answer? You guys work together. We did this with. You guys work together in the World of Volvo project, so you have a perspective where you're working the efficiencies of what you learned. If you could talk to that, if you did it again, World of Volvo again, I bet it would be. You've learned a lot. It'd be more efficient.
If I do it again, I would do it like in a forest without the glass facades. So it's just sitting in a landscape.
Yeah.
But yeah. I think if I do it again in terms of sort of digital, those issues that we had, I think we would have brought in experts much earlier in the process. We tried a lot ourselves in the beginning, and we also tried with the collaborating engineers that we had at the time, which couldn't really figure it out in wood, to be honest. And we have learned a lot through that process. Of course, it's a really complex wood structure compared to you know, a more of a grid, a regular structure. But in that regard, it was really on the edge of what we also as architects were sort of used to doing. And that was really challenging, of course. And we needed experts to figure it out. If I would have gotten to know you before, maybe that could have helped. Or also the industry. I think we let's shift cards afterwards. But I think we also approached. We had fortunately there were some guys from Blume Lehmann, for example, in Switzerland also that came by the office early on that we started to talk with the project about with them and they helped us out to figure it out and so on. So yeah.
Well, you've gone through that learning curve that I think every company has to, and now you have that advantage. You may not have another World of Volvo, but you'll have a lot of lessons you can apply.
Yeah.
So the question becomes, well, do you focus on marketing that knowledge here locally, or do you?
No, we do that internationally. I mean, in terms of the American, we have an office in New York, so it's more. I don't know that much on how much focus they have, to be honest, on wood. But I would say that we are definitely learning from this, and from we have plenty other wooden projects at the moment as well, and I think we're applying that knowledge more and more. Also internationally, but I think the challenge internationally is that the focus we have as architects is mostly involved in sustainability questions or carbon and things like that. That's our arguments for making things in wood, and that's not necessarily the main focus in all parts of the world, unfortunately, at the moment. So I think that's the main challenge, I guess.
Yeah. Okay. The way we ask Stefan too, but you've gone through it too now. You can do crazy complex project like World of Volvo. What to go after now, or how to apply those lessons?
We were very fortunate together that we had a contractor client which was foreseeing that brought us in really early, and that we had a design stage which was quite long before we had to give a final price. So I think a lot of the troubles that occur in the industry today is due to the type of contract you have with or the architect has with the client, and then they will buy a contractor and they will find the people. It's never this on the side.
Yeah.
So it always goes up and down and here and there, and it gets really complicated. So if I can do it again, I would find a really a contractor which has the knowledge, and then bring us in together as a team, and then we do as large packages as possible. In our case, it was perfect. We had the wood, we had the glass, and all the acoustic panels. So we had a model which could take care of everything, and no interfaces. So that is my message to the contractors in that case.
And you've gone through that now. What's your kind of interest moving forward? Are there projects that come in, or do you go out to more countries, other markets?
Well, Lindner is a worldwide company, so my market is Scandinavia. If I go over there, they get really angry. So,
but your knowledge and experience to disseminate that even within your own company.
Yeah, we have a facade group which is active all over the world, and we try to implement the knowledge of the wooden structures and the wooden facades or timber facades, and try to market that to the rest of Europe and the world. In Germany, for example, it has been forbidden to have combustible materials in the facades for a long time. Starting to change, so it's a lot of legal and things in the way to actually do it, but. And in America, we did a House of Sweden a long time ago, embassy in Washington. And there is a lot of union issues, and if you don't know it, you can get in a lot of trouble, basically.
Well, we certainly have a lot of legal challenges in the way the whole bidding system works, as well as the way contracts function in the U.S.
Yeah, if you read a contract in the U.S., you get really scared.
Yeah, you want to be a contractor, then you should be a lawyer.
Yeah.
Okay, great. I want to ask Enlai, you're like a lot of what I like. The Scandinavian architecture travels really well. It's really easy to sell Nordic design, and that's the good news. So we're seeing firms like yours and more Danish firms or Nordic firms getting projects in the U.S. So and Canada as well. Let's look at it as a market.
Yeah.
What are you seeing in your exposure to doing big projects there?
Okay, so the drop is that we are actually part of Perkins & Will, which is the second largest American architecture firm, and probably the fourth, I think it's the fourth largest in the world. Mm-hmm. So a lot of what we do already is in the US. Okay. And I'm heading the research across the board in adaptive transformation. So this is like, it's a research-based organization. And so there are many areas of research. Mass timber technologies is one of those areas of research, and I'm very closely related with that. Mm-hmm. And adaptive transformation is a research topic that I'm overseeing, and we're very closely connecting that with the Building Technology Lab, which is handling mass timber building. So, and technology. So, would we like to be in the US? Yes, we would. Yes, we are. Mm-hmm. And the other question about that is like, what value can we bring to each other? I mean, because we are, in a way, separate companies all held under the same umbrella, and we reach into each other with research and different, areas of practice and IT and technologies. But I would say the thing that we always have to do is meet people where they are, meaning that the US and Canada actually is ahead of us in some areas and behind us in other areas, and it's actually super valuable to have this sort of open and sharing attitude across borders. And we're always looking to partner on every project that we do. So it's not one of these things to say, would you be interested or not? It's the automatic answer, of course, is yes. But the real interesting question is like, how? Mm-hmm. And I'll let someone else take that on.
Yeah, Fabian, and I'll just ask that question then to Steve, but then I think we'll take questions from the audience. Yeah. I'm sure you have them. So
I also don't know how. I found your point very interesting when it comes to complexity in timber. Just one point I want to make. You've seen the two projects that I've shown. Swatch, 11,000 square meters of doubly curved timber grid shell with 2,800 individual facade elements on one side. And then this 8-story timber building, basically pretty straightforward, rectangular, repetitive, it seems at least. We've put almost equally many work hours into both projects to get fabrication data out for them, because the one seems more complex because of its funky geometry, but it's nicely sorted. We have 10 different facade element types, and there's 10 different connection details to the timber structure. The other one seems simple because it's rectangular. We have about 1,000 windows in there and 92 different facade details to connect them to the timber structure, because someone just didn't pay attention and reinvented new details on every story in every building sector of the house, for example. Which means I have 10 times as much to do with one connection as I have with the other connection there. And I think that is the lesson that we need to learn. Timber is a bit more complicated when it comes to the detailing. So the earlier you basically start kicking out options and basically try to find at least something that where one size fits all. I mean, it's not possible in all the cases, of course. But if you don't start getting the complexity out of the project early, it'll just multiply over the way until the very end, and that means you have 10 different strains going down into fabrication for those details in the end. And the way we're dealing with that is always, okay, we hire more people that detail things. Yeah, there's unlimited workforce out there that basically creates 2D drawings. And that was the case, and that still is the case, but the CNC machines cannot read 2D drawings. And that's the main problem that we're having here. So don't be fooled by the seemingly simpleness of orthogonality and the complexity of curved geometries. Actually, it's often the other way around.
And we have to figure out how to clone Fabian. We discussed that.
That'll be interesting.
Steve, I have a question for you, then we'll take questions from the audience. Based on those Helena's presentations and just all of the other ones, how do you see that possibly applying to the U.S. mass timber market? That's a tough one, but
well, that's pretty broad. I mean, it all applies. I think one of the things that we're all experiencing right now is this is something that we're all in the early phases of learning about. The technology itself is young, and then the people coming to it, more commonly than not, are coming. It's an initial step, and they don't necessarily have boatloads of mentoring along the way, et cetera, as we do for some other things that we've done. It's a different kind of step forward. You don't have the same degree of professional safety net. I was fascinated a while ago. I was invited to sit in on an internal meeting, global corporation that has done mass timber work around the world. I knew several people in the meeting from around the world. They had never met each other before that meeting. And the fine work they were doing, they were pretty much doing it, crafting it without the benefit of the knowledge that was in their own corporation. And it just sort of hit me about, wow, okay, there's some inefficiencies here, et cetera. We are seeing in the U.S. right now, many of the larger players deliberately building up a mass timber muscle within their organization. They've done some work. Maybe someone did a project on the East Coast, someone else, did one on the West Coast, et cetera. Then they're sitting back and going, okay, how do we, as a larger body, best work with this? And I think the answer for that will be different for different players. But we're at a point now where there's enough of it out there where that question is being asked again and again by different players. And so, I think some of the, the sense that many of us have had, myself included, about how fragmented this is. I think a lot of that is just sort of a manifestation of just, we're at the low starting point on that big inflection curve, and and as we work further up it won't be so choppy.
Mm-hmm. Great. I'm sure we'll have a chance to network immediately after this panel, but there must be some questions, I assume.
Hi, thank you for the insight. It was super interesting to hear you all.
Oh, yeah.
Yeah, for the people at home.
Hi, thanks for your insight. Very interesting. Just a general question is there anywhere where it doesn't make sense to build in wood in your mind? If you have any insights both on the North American market or the European one, in the sense that if we make it specific to mass timber. Is there a scale where it makes sense or doesn't make sense to go for wood? And is there places you see in the world or in those countries where it may not always be the answer? And that basically is the depth of steel and concrete structures if we can have enough wood available to build in wood. Thanks.
Wants to take that?
Yeah, I mean, I'm not an engineer, but from all I hear, second-hand knowledge, I mean, it's not about timber is the only solution to the problems that we're having. Timber is good in some places and probably pretty bad in other places, and the thing is that I think timber needs a fair chance to basically play on its strong sides to become more prevalent in a way. This is changing now also with regulations. I mean, we have the EU taxonomy that basically says the economic situation for different types of material is changing in the building sector. That doesn't mean that you cannot build with concrete anymore. It just means relative to timber, it probably becomes more expensive. So you will start thinking about where can I actually use this because it's beneficial, and where do I replace it with something that is cheaper and does the same job. And that, I think, is the important thing that we need to think about now.
Sorry. It might be worthwhile going just ahead because I'm going to address your question with more questions. So you can answer them. And the point is that obviously there's no silver bullet in the material industry, there's no silver bullet in the building industry. Timber has its drawbacks. It's fantastic for carbon. It's a renewable resource. But, mass timber often uses polyurethane glues or worse. It has certain qualities that make it, not very good for different parts of buildings and structures. Mold and moisture can be an issue. So, yes, they can be overcome, but, you need specific, qualities of envelope or knowledge and crafts. So part of the story comes down to the human capital and the knowledge base and the ability to actually do this work of pre-engineering and designing. Another one comes down to the idea that perhaps timber is, once it becomes mass timber, is not circular in the sense that you can't put it back into the ground. It's a mixture of synthetic materials and natural materials. And of course, you can put stuff back into the ground if it will decompose, but mass timber has elements that will not most of the time, unless there's lignin binders, but we haven't really gotten there on the larger scale yet. So then the third part is land use. And we know that when you've got a green area, and not all green is the same quality of green. So if you've got a patch of grass, you're looking at a biodiversity desert. If you're looking at a forest, it depends what kind of forest, whether it's biodiverse or not, right? Whether it's actually regenerative or healing. So when you can have managed forests, of course, but in a lot of cases, those managed forests are one type of tree, and that's not terribly good for biodiversity. And if you're making resource demands from the building industry on land use, it's not only the quality of the soil and the lack of biodiversity, but the pressure on the food system and the pressure on all of these. And biofuels have got even worse story to tell about that. So the answers about whether it is or it is not appropriate demands a level of research on a case-by-case scenario that I don't think you can have a simple answer for in the first place. So I'll leave the complex answers to you.
It's a great question. Just a sort of a side note, when I first got involved in mass timber, there were some pretty clear understandings about where the construction would be suitable and where it would not be suitable. And I'll tell you that right now there's been a lot of successful construction in situations that earlier people were saying, no, it's not going to work there, here's the reasons. And yet it has happened several times in different ways. For me, when I heard your question, the thing that I went to that was most important for me actually goes back to what you were just talking about with where the material comes from, because you can't have sustainable buildings made out of wood if you don't have sustainable forest. And we don't have sustainably managed forest globally at this time. And so I think, in part, that the focus on these buildings being sustainable, will force a discipline within the supply chain that is very uneven at this particular moment. And around the world, I'll just say the societal situations are different. The governance situations are different. I feel pretty good about where we are in terms of forest management in the United States. Even within the U.S., we have a fair degree of variability. I feel very good about the overall mix, of where we are. I feel very comfortable in that context, talking about these sustainable buildings being connected to sustainable forest. But I think in terms of the long-term and broad use around the world, that to me is probably as important as anything else related to mass timber. If you're going to truly be doing sustainable buildings, there needs to be a true sustainable story behind the building. That's my speech on that one.
And I want to add an answer too, because people look at me like, and I view the world from a digital fabricator's perspective, and they're like, you're a wood guy, you must hate the concrete guys and the steel guys. It's not true at all. People I know well who are digital fabricators of composites, metals, and doing great stuff with concrete. So I said, no, it's not material versus material, it's process. It's digital versus analog. Every building we do is hybrid. And so let's use the right material and let's do it efficiently and figure out how to get from bits to atoms for that particular type of building. I think it's wasted energy to spend time on material wars. Just my view. Any other question? Yeah, go ahead.
I totally agree. I think that there's a lot of focus on digitalization, for example, in the concrete industry as well, 3D printing in concrete to minimize material use and so on. But I think it's also a lot of focus on the sort of the opposite of digitalization, going back to the basics of how we built maybe 200 years ago with rammed earth as a possibility, or other ways of looking at sort of the locally sourced materials as a building component, not only wood, because there's of course a lot of places in the world where wood is a scarce commodity or material.
Yeah, we're lucky we have a lot of wood, so we're going to build a lot with that, and we've got plenty to do without saying go away from concrete and steel. There's plenty to do. And another question.
Hi, and thank you so much for all your presentations. Being a structural engineer with a lot of grasshopper and timber, I always have a question for you, Martin, with your amazing project Volvo. There's not a lot of talks from engineers today, but I hope we're welcome. And maybe you touched a little bit on it, because it seems like a really great workflow with the parametric stuff from the beginning and also to the end with the contractor. How was it with engineering? And seeing that model, the parametric model, and knowing that how important it is with timber and the connections exactly, and how many connections you'll have in terms of cost and the angles and so. Did you have a collaboration on that, or how would that be? Yeah.
We had a big collaboration in that, but it took a while before we established that collaboration. I think, as I said, the first ones we met in the industry that could help us out with the scripting and sort of helping us out. We made the script, but the first ones we could actually send that script to and get a feedback back on it. That was Blume Lehmann in Switzerland. And then we worked a little bit with them, and then through the client and the process with the client and the contract came in, we also found VHAG, and there was, of course, a sort of as it is in the building industry, a bidding for who could do it the cheapest way. And then we started working with VHAG, and the same went for them, and then further on with also Lindner when it came to the glass facade systems and stuff like that. So I would say it was tough before we found the right companies or guys to collaborate with. It took us quite a while to figure out who we could. I mean, the local engineering company that we worked with through the client at the beginning, they couldn't figure it out. They didn't have the means. They had a one engineer in their company, a young girl who tried and really were engaged in working with Grasshopper and Rhino, but it was too much for her, unfortunately. So I would encourage more engineers to work with this, absolutely. Yeah.
To stay on schedule now, I think we'll move to the networking, so you can ask the questions all in person. And thank you to the panelists, it was great.
Thanks.
And thank you to the audience.
And just a very, very short ending note. I think I said in my presentation that we were up for a buffet of great keynotes, and I hope you joined me in really, really hitting that nail this afternoon. So thank you very, very much from BLOXHUB, from me, of course. Thank you to you, Greg, for organizing. Thank you to Peder for organizing. Thanks to you, Stefan, coming. You, Steve, Martin, Fabian, Enlai, for great presentations. Ending on, was it 100 slides in 10 minutes? Roughly 10 minutes. That was a great ending note. But this will be the end of a great afternoon of very, very important high quality keynotes and high quality discussions. And thank you for your questions also. But it will be the startup of the networking session that you just mentioned. So please approach these gentlemen in order to create contacts, and simply just learn from the skills we have in front of us here this afternoon. Thank you so much for showing up. Do some great networking afterwards. And then lastly, the very, very last commercial here, that in BLOXHUB we do support those of you who are interested in doing more business in the US. My colleague Martina over there will gladly take your questions in order for you to get on board some of the activities going on here on a running basis in linking up Danish and US-based businesses, both within the mass timber industry or in the urban built environment in general. So please approach Martina if you have any questions and any wishes there. Thank you so much for showing up, and let's all go out here with some of the participants already showing up for the AEC Hackathon. We're going to start up the AEC Hackathon in just a couple of hours. So if there is a bus out there, that is part of the participants already showed up. So I hope you accept that. But do please, let's get outside, do some networking, and thanks for your participation this afternoon. Thank you so much.